Hi everyone, welcome to this Math OED2 video. In this video, we are going to continue learning about difference of squares. So we're going to continue with some more examples of factoring difference of squares. So remember, our factoring procedure is that first we look for a GCF. In this example, our GCF is 1. We then ask ourselves, how many terms do we have? In this case, we have 2 terms. So remember, the only technique we have for factoring polynomials with 2 terms is difference of squares. Now, other techniques might exist in mathematics, but in this course so far, this is the only technique that we've been exposed to. In order to use the difference of squares definition, I have to first make sure that both terms are perfect squares and that the terms are being subtracted from one another. So if we look at the square root of a to the 4th, that's a squared. And if we look at the square root of b to the 4th, that's b squared. So these are both perfect squares. Are they being subtracted? They are. Therefore, we can use the definition of a perfect square to factor this polynomial. So our first term is going to be a squared. Our last term is going to be b squared. And one of these should be addition and the other must be subtraction. Now, take a minute and look at what we have here. I'm going to rewrite it up here just so you can see it better. We have a squared plus b squared times a squared minus b squared. Look at what we have and think about if there's anything else we can do with this answer. If you want, you can pause the video and give yourself extra time to think. Did you notice that the term a squared minus b squared is itself a difference of squares? So unfortunately, we have to do more work. We have to continue to factor this binomial. So a squared plus b squared, as you can tell, is a sum of 2 squares and is therefore not factorable. But a squared minus b squared is a perfect square and can be further factored into a plus b times a minus b. So our final answer is a squared plus b squared times the quantity a plus b times the quantity a minus b. That is our final answer. So as you work through these problems, get used to looking at an answer and asking yourself, is there anything else I can do? Is there any more to be factored? And make sure the answer is no before you move on to the next problem. Let's do another one. So again, we're looking at our GCF, which is 1. We're looking at 2 terms. And so we're going to try to use the difference of squares method. So the square root of x to the 4th is x squared. The square root of 16 is 4. And again, we've made sure that both things are perfect squares. Then we make sure that they're being subtracted from each other, which they are. So we can use the definition of difference of squares to factor this polynomial. So we have x minus 4 times x plus 4, or you could have written them in a different order. Again, notice, as you look at this, that x squared minus 4 is itself a difference of squares. It can be further factored into x plus 2 times x minus 2. And again, we have to bring down the rest of the problem, which is x squared plus 4. So that's our final answer. Let's do the last problem. So remember, our very first step is to always look for our GCF. What is our GCF? For once, our GCF is not 1 anymore. Our GCF is 2. So we have to factor out a 2 from both terms. Then we note again that we have 2 terms, and so we need to find a difference of squares. If I take the square root of 36x squared, I get 6x, and if I take the square root of 1, I get 1. And again, I have to make sure that this is a difference and not a sum, which indeed it is. So now I can continue to factor 36x squared minus 1, and it factors into 6x plus 1 times 6x minus 1. Now remember, the 2 is still part of my answer. So my final answer is 2 times the quantity 6x plus 1 times the quantity 6x minus 1. That is my final answer.